Hi guys, it's Miss Earl here, and let's go ahead and jump into this assignment today. It is Unit 9, which is all about surface area. Later we'll be getting into volume, but today's lesson specifically is problem solving with surface area. So we're still finding the area of surfaces. Here's a really quick overview of what you'll be doing today. If you can find the area of a rectangle or a square, which is base times height, then you're going to do really well. And if you can find the area of a triangle, and remember that they're different, then you're also going to do really well. If this is the base on your triangle and you also have the height, in order to find the area of a triangle, you have to do base times height divide by 2. All right, so once again, if you can do those two things, you're going to do great. Let's go ahead and get started. Here's your learning target, which is I can use surface area to solve real-world problems. Let's begin. Surface area can be used to solve multi-step problems. The cereal box shown at the right is cut from a piece of cardboard that measures 600 square inches. How many cereal boxes can be cut from this piece of cardboard? The very first thing that we need to know is how many boxes can be cut from this piece of cardboard. And I'm going to write that out. And in order to find out how many boxes can be cut from this piece of cardboard, we're going to have to find the surface area. Piece IE. There we go. How many pieces or how many boxes can be cut from this piece of cardboard? And here's what we do know. We do know that the cardboard that we have has a total of 600 square inches. So let's go ahead and work this out. We're going to take it small steps, just one side of the cereal box at a time. We need to find the surface area of this very front side that says cereal on it. And in order to do that, because it's a rectangle, you're just going to do base times height. Well, my base is 8 and my height is 12. 12 times 8, that's going to give us 96. Okay, so here's what I know. The front side of my box is 96 inches squared. I also know that the back side of my box is also 96 inches squared. So let's add another 96 inches. So far I have 192 inches. That includes the front and the back of my box. And sometimes I like to show you guys exactly what you'll be seeing. If you wanted to see the back side of the box, it could kind of help you envision it. All right, so we got 2 sides of our box done. Let's go ahead and pick another side. All right, I'm going to say I want to find what the front, or sorry, the top panel of my box is, and also this bottom panel. And in order to do that, I need to find my base times my height. It looks like our base is 2 inches and the height is 8. Let's multiply them together because a rectangle you always do base times height. 2 times 8, I get 16. That was for the bottom panel. Look, the top is also 2 by 8, which is also 16. So let's add 16 again. 16 plus 16 gives us 32. And we need to add that to 192 because we already had that number before. So 192 plus 32 gives us 224 so far. We still are missing the side panels. All right, so this side panel on the left and this side panel on the right that you can't see at this angle, so you'll just have to use your imagination. Kind of draw it in there for you. We're just going to do the base, which is 2 inches, times the height of the cereal box, which if I look over here, it tells me the height is 12. 2 times 12, that is 24. That's going to say, so 24 is this one panel on the left. but 24 is also that orange panel on the right. So let's go ahead and add 24 plus 24. And now I need to add that to my old running total. Let's go ahead and add all of them up together. $272. What is that telling us exactly? Well, what we did was we found the surface area of our cereal box. So our answer, because it's surface area, is going to be in inches squared, because area is always squared. Don't forget it. Now here's what our answer is going to be. The question, if you'll refer back to question number 1, it says the cereal box shown at the right is cut from a piece of cardboard that measures 600 square inches. How many cereal boxes can be cut from this piece of cardboard? So we're going to have to take 600 and divide it by 272 in order to find, and I'll write 272 in a different color, in order to find how many boxes we could, cereal boxes we could make. I'm just going to use my calculator. 600 divided by 272 is 2.2 blah blah blah. Guess what? It doesn't matter, because we only want to know how many cereal boxes we can make. We can make 2 entire boxes. The rest of it, we don't really care about the rest of it, because we just want to know how many boxes we can make. Well, we can make 2. So 2 entire boxes, that is your answer. And once again, this relates to the top part where it said surface area can be used to solve multi-step problems. That's very true. The problem that we just barely did is a multi-step problem. That took us quite a few steps, but we ended up getting it, and so that's what matters. All right, question number 2 talks about a square pyramid and a cube that have the same total surface area. The length of each side of the base of the square pyramid is 12 meters. This question we ended up skipping in class because it was so hard. I'm going to try my best to complete this. I know what the answer is. I've only had like 6 students who felt challenged try and complete it. So if you don't want to do this problem, or you don't want to feel overwhelmed, feel free to skip it. I'll go through it and just try and write these out. So here we go. A square pyramid and a cube have the same total surface area. The length of each side of the base of the square pyramid is 12 meters. Well, I'm just going to show you really quick what a square pyramid will look like in a net. So I'm just going to draw it out like this. It's going to have one square, and then it's going to have some triangles, right? And it's telling us here that the base of the square pyramid is 12 meters. And I'm going to make sure that I use a different color. If the base here is 12 and it's a square, that means the height is also 12, okay? Now the width of the cube is 6 meters. What's the lateral height of the square pyramid? Lateral height means, what is this line right here? What is the height of one of the triangles? Well, let's go ahead and draw out the net of a cube. Now, if I were to draw out my cube, it's going to have 6 different spots. This is just one example of a net. Yours doesn't have to look exactly like mine. And over here in the question, it says that the width of the cube is 6 meters. Well, because this is a cube, which is perfectly square, that means all of the sides are going to be 6 meters. Let's do a little bit of math so far. Well, the base times the height, that means 6 times 6. That's going to give us 36 meters. Is that one square? But because it's a cube, all of these are going to be, all these squares are going to be the exact same size. So let's refer back to the question because this is really important. A square pyramid and cube have the same total surface area. Let's try and solve for the surface area of this cube down below because we've already added up. We've already figured out what each square is when it comes to surface area. Let's add them all up. In my calculator, I'm going to type out 36 times however many squares we have here. And it looks like we have 6 squares. So I'm going to say 36 times 6, and that gives me 216. What this tells me is that my surface area of the cube is 216. Well, in the question it said at the very beginning that the cube and the square pyramid have the same total surface area. So I know my surface area of my square pyramid has to be 216. Alright, so the length of each side of the base of the square pyramid is 12 meters. The width of the cube is 6 meters. What is the lateral height of the square pyramid? Okay, this is awesome. Let's go ahead and figure out what this portion of my square is going to be, the one that I'm highlighting right now, because we can use that to our advantage. In order to do that, we have to do base times height. And base times height will give us the area. Well, our base is 12 and our height is also 12, and that's going to give us 144. So this square right here is 144 meters. All right, now when it comes to a triangle, area of a triangle is equal to the base times the height divided by 2. Let's try and think about what we know so far. We know that the base of the triangle is 12. How do I know what the area of all the triangles are? And I'm also, as we go through this, I'm going to erase the B for base, and I'm going to plug in what we do know. We know that the base is 12 because it says over here, the base of our triangle is 12 here. The base of our triangle here is 12. All of the bases are 12. We need to figure out what the area of all the triangles added up together are going to be. And in order to do that, we are going to have to take our total area, which is 216, our total surface area. We're going to have to subtract the square, which is 144. And that is going to give us the total surface area of the 4 triangles. So let's go ahead and do this. 6 minus 4 gives me 2. I'm going to have to regroup. It looks like I got the total surface area for the 4 triangles is 72. And I'm also showing my work so that way you're aware that the 4 triangles equals 72 meters squared. Okay, now we just want to be able to find the area of one triangle. So let's go ahead and take our number 72 and let's divide it by 4 so we can find what the area of just one triangle is. I'm using my calculator and I got 18. So that means each one of these triangles is 18 in area, just in surface area. Well, that's not even the question that we have to answer. They said, what is the lateral height? And the lateral height, once again, maybe I should use a different color. We'll use this bright green. The lateral height is the part of my triangle that is measuring from the base to the tip. So, in order to do this, we have to plug in what we do know into our equation. Our equation is area equals base times height divided by 2. We know what number the base measures. The base measures, let me pick a good highlighter. The base measures 12. So let's plug in 12 for my base. I'm just going to go ahead and erase it right here. I'm going to plug in 12 for that number. What is the height? That's what we are unsure of. We don't know what the height is, so we're going to leave H for height. What is the area? We know what the area is because we found it right here. Oh no, I'm going to undo that. I thought I was on my highlighter. Here's the area. It's 18. So let's go ahead and plug that in all the way over here for A. So I'm going to erase area and I'm going to write in 18. All right, here's what we have so far. 18 equals 12 times the height divided by 2. Now, this looks to me like a two-step equation. And I'm going to go ahead and write it all out under right here where it says my solution. I'm going to change my pen size so it's not so large. Here's what we have so far. 18 equals 12 times the height divided by 2. This is now a two-step equation, which we have been solving these all year long. First step, get rid of the 2 on the bottom. Our equation is being divided by 2. We have to do the opposite, which is multiply. So let's multiply by 2 over 1 on this side, and our 2's cancel out. Multiply by 2 on this side, and we're going to get 36. Let me just double check. Yes, 36. And let's bring everything down that we haven't used. So I'm going to bring down my equal sign and my 12 and the H for height. Okay, this is looking pretty good, but we still have to get H all by itself. So let's do the opposite of multiply by H. You'll see right here 12 and H are being multiplied. Opposite of multiply is divide. So let's divide by 12 on both sides. And now we're left with H equals 36 divided by 12, which is 3. So the lateral height of our triangle way over here equals 3. Wow, that was so much. I also forgot to fill in a couple spaces. The first thing that we do know is the cube side length was 6 meters. What we needed to know was the lateral height. So I'm just going to say lateral height. You could say lateral height of the pyramid, or you could just say lateral height. Now, once again, this question, if this confused you, I know there's a lot going on in this picture too, just this visual. This one was for my students who like to be challenged. This was kind of a bonus. In class, we skipped this one because there was so much to this. We didn't feel like this was kind of on grade level. We thought it was beyond 7th grade math. But I know I had a lot of students who still wanted the answer and wanted to be challenged. So here you go. This is for you guys. Okay, question number 3 says, a shoebox is covered with packing paper before being shipped. The paper costs 1 cent per square inch. How much will it cost to cover 3 pairs of shoes? Like we said earlier, we're solving multi-step equations. Let's start with the very first thing that we know. We know that the paper costs 1 cent per square inch. So I'm going to put per inch squared. Here's what we need to know is the surface area of our shoebox. You could shorten surface area to just SA if you wanted, or you could write out surface area. Surface area of the shoebox, that's what we need to know. All right, let's go ahead and work this out. The very first thing is I need to pick a side of my shoebox and go ahead and find the surface area. Here we go. Now, our base, it looks like our base is going to be 16, and our height is going to be 8. Why am I doing 16 times 8? Well, because surface area of a rectangle is equal to the base times the height. So our base was 16 over here, and the height is 10. No, sorry, the height is 8. I'm going to show you how I got 8. I see this height is equal to my height over here that says 8. Okay, so let's go ahead and write that down. 16 times 8 gives us 128 inches squared. That's just for one of these boxes. I'm going to show you something. If you were to go ahead and draw some lines, you would see that there's also a back panel back there. That is also going to be the same exact size as the front. You just can't see the back of the shoebox, right? So the back is also going to be 128 inches squared. So let's add that to it. I'm going to say 128 plus 128. Let's see what that gives us. I got 256 so far. Okay, well, I'm going to erase my work and let's go ahead and solve for another two sides of the shoebox. Now I want to solve for the top of the shoebox. And the top of my shoebox is going to be my base times my height. Looks like my base is 16. And my height is 10. How did I get 10? That is the big question. How did I know that this side right here was 10? Well, if I look directly below it, these two lines are parallel. The bottom line is 10, so I know the top line has to be 10. Let's go ahead and do 16 times 10. Well, that gives us 160 for the top panel. And I know the bottom panel, like underneath the shoebox, the part that we can't really see, will also be 160. So if I have 160 on the bottom and 160 on the top, let's go ahead and add those two together. And I'm going to add it to my running total. I have 416, but I still need to add another 160. I'm going to show all my work and just keep carrying it over. So I'm just adding the bottom of my shoebox now. I have 576. There are still parts of my shoebox that I need to go ahead and measure. The first part is, let's do the right-hand side of the shoebox. And we still need to do the left-hand side of the shoebox. So in order to do that, we have to do base times height because it's a rectangle. My base is going to be 10 and my height is going to be 8. And I see same thing over here. It will be base times height. Because the shapes are parallel from each other, they will be the same size. And so 8 times 10 is 80. And I have two panels that are both 80. 80 plus 80. Well, 80 plus 80 gives me 160. So let's add 160 to our running total. And I get 736 inches squared. Whatever you do not forget to square your answer because it's inches squared because it's area. All right, so that was the first part of the question. The next thing says that the paper that we're going to wrap the shoes in for your dad's birthday, it's going to cost 1 cent per square inch. Well, there's 736 square inches. We need to multiply by 0.01, or 1 penny, in other words. And if you do that, we're going to get 7.36. So we took our square inches, our inches squared, we multiplied them by 1 cent. That's going to tell us how much it's going to cost to wrap the shoebox. So it's going to cost us $7.36 to wrap the shoebox. Well, guess what? There are 3 shoeboxes here that we're going to have to wrap. So we need to do the price of 1 shoebox, which is $7.36, times that by 3. And if you do, we're going to get $22.08. So the answer to our solution is $22.08. Wow, that was quite a bit of work. Like we said earlier, we can use these problems to solve real world scenarios, whatever. And yeah, it does take quite a bit of steps, but you can do it if you're patient and you just break it down. All right, let's go ahead and solve the fourth question, fourth and last. This one says decompose the shape below into 2 rectangular prisms, then determine the total surface area. All right, I'm going to take my 2 rectangular prisms and I'm going to divide them. Well, it was 1, so now we have 2. It was 1 shape. We broke it down. Now we have 2 shapes. First step, let's go ahead and add up our sides. This problem could be mind-blowing depending on how you see it. But some of you might be like, heck yeah, let's go ahead and start this. So let's go ahead and start this. I would just want to find the very top portion. it looks like it's going to be, I should probably use a different color than black. Let's see, we have a base of 4 and our height is going to be the same height as over here. 3 centimeters. This height down here is also 3. That's how we know. So let's do 4 times 3 and we're going to get 12. 12 centimeters is for that yellow highlighted part of a rectangular pyramid. Okay, I think we did it. There's something else we need to realize. There's also a bottom part of the pyramid that will be, not pyramid, sorry, prism. There's also a bottom portion of the prism that will be the exact same, which is 12. So I need to add another 12. And I'm going to get 24. Let's erase what we have so far, because now we need to find another side. Okay, now I want to find this front side and the back side, just opposite or parallel. But in order to do that, I need to find the base. My base is not 7. 7 spans all the way across. Here's my question for you. How can we figure out what just this portion is right here? Well, if you look directly above, it's 4. So our base is 4 and our height right here is going to be 3. And 4 times 3 gives us 12. So whatever you do, don't let this guy stump you, because that guy will stump you. All right, 4 times 3 gives us 12. So our front panel is 12, and that means, let's draw this in a different color. That means this back wall that you can't really see back here will also be 12. 12 plus 12, that's another 24. Let's write this out. I'm going to add another 24, and that's going to give us 48. Now there's another part that we need to try and find the surface area of, and that's this end piece of our rectangular prism. And here we go. All right, I need to find my base right here. Well, it's going to be the same base as over here because they're parallel from each other. So it's going to be 3 centimeters. I also need to find the height. It looks like the height is another 3 centimeters. And that's going to give us a square right here. 3 by 3, that is 9. Something that's important to recognize. Let's go ahead and add that together. And I have 57. So my surface area for the shape on the left side is 57. Let me go ahead and divide this again. We have found the entire shape on the left-hand side, and now we're just focused on that tall tower on the right-hand side. So let's take a look at this panel right here. It looks like the base is 3 and the height is 8. Well, 3 times 8, that's going to give us 24. So let's add 24 to our 57 that we had before. And that's going to give me 81. Now we need to find the other side. I'm going to highlight in a different color actually, orange. Let's use orange now. We want to find this rectangle right here. I have students who look at that and they say, oh, well, that's 24, and they're just kind of guessing. Well, we know, let me do some erasing over here. We just want this orange panel. You might have to use some subtraction to figure out the answer. We just want this portion right here. Well, if up here was 4 centimeters, and now where I'm highlighting in blue is what's left over, what's this original 7 centimeters minus 4, that will give us our measurement, which is 3. And then we still need the height. It looks like our height is 8. I know that because directly parallel to it says 8. So that panel is also 24. Let's go ahead and add that. I have 105 so far. All right, now we need the back panel. And that means that the panel directly behind that we can't even see will also be the same. I can kind of show this to you by using my pen here and drawing. If I were to pretend right here that there were a backside, it would also be 24 as well. So let's add another 24. I have 129. There are still 3 pieces that I can see that I'm missing, that I know of. The first one is the very top portion and the bottom portion. Let's draw a picture here. Okay, I know that my height is 3. My base, we've talked about this measurement, is also 3. Well, 3 by 3 gives us 9, and the top is the exact same measurement. 9 plus 9 is 18. Let's add that to our 129 that we had from down below. 129 plus 18, and that's going to give us 147. Okay, now there's just one more part that we still need to get. And that is this part over here that's hiding from us. It's facing away, and you can't even see it, but you have to imagine it. This is where things get tricky. All right, we need to know what our height is going to be. Well, let's use a different color now. Green height over here says 8 centimeters. How can we figure out, oh, here we go. We have 3 centimeters tall is over there. That means to here would be 3 centimeters. 8 centimeters, take away 3 centimeters, leaves us in orange with 5 centimeters. So we know that our rectangle is going to be 5 centimeters tall. And we already found this length right here, and it was 3. So 3 times 5 gives us 15. That just barely gave us the back wall that we can't really see. So let me go ahead and erase that so you can try and visualize. 15 is that sneaky thing that's hiding behind the corner over there. 15 centimeters. Let's go ahead and add that to our 147. I got 162 centimeters, and there's one thing that I'm missing. Hopefully you've caught it. Squared, because they asked us to find the surface area over here. So don't forget you need to square your answer. Wow, that was a lot. Okay, I'm not even going to fill out the top parts. What we knew before, well, I guess I can fill them out, was the dimensions. What we needed to know was the surface area. So take all those dimensions and find the surface area. Wow, that problem was quite the problem. So I understand on your homework if you make a mistake, because if you make a mistake early on, you have to redo the entire problem. Anyways, your homework, if you have any questions on it, please come and ask me. I'm here before school. After school, you can get requested during shield time. You can also stay in during lunchtime and I'll help you out. Please just let me know what I can do to help you succeed. After this, we're moving on to volume. So hopefully you have mastered the idea of finding the area of a rectangle, which is base times height, and the area of a triangle, which is base times height divided by 2. All right, thanks guys for watching. You're awesome.